Welcome back, Math Marbles. This is lesson 66, finding the probability of simple events. As I'm modeling, I want you to look out for a few things. One, watch how I express probability of an event as a fraction and how I convert that fraction into a percentage or even a decimal. And finding how I contextualize the event in the context of probability. Let's look at our first problem. A cereal company puts a colored ring in each box of cereal. There are 6 different ring colors. The colors of the rings in each of the 50 cereal boxes are shown in the table below. What is the probability of selecting a green ring? What is the probability of not choosing a purple ring? So we pretty much want to know the P of green, the probability of green, and the probability of not purple. Here's what we know. We know there are 50 rings in all the colors. We see all the outcomes there. We know that 8 are green and 10 are purple. I'm not looking about all the others. So if I know 10 are purple and I want the ones that are not purple, out of 50, that means 40 are not purple. My plan is pretty simple. I'm going to represent the probability of green as a fraction. We already see it here, 8 out of 50. And then I'm going to figure out the probability of purple as a fraction and then convert those fractions to percents and decimals. Hit pause and jot this down into your notes. Let's express the probability of green as a fraction. We can see that there are 8 green out of 50 total. So we have 8 over 50. I'm going to simplify that to 4 out of 25. Now let's turn that into a decimal. 25 going into 4. And you can see I'm automatically putting a decimal and 2 zeros there. So it goes in there one time. That's 25. 15, 150. 25 goes into 156 times. That makes 150 with no remainder. So the probability of green is equal to 1600 or 16%. This leaves us in the unlikely realm. Let's look at the second one, and we want the probability of not purple. So we know that again there are 50, and since I know there are 10 purple, that means the other 40 are not purple. And I'm going to simplify this to 4/5. So let's change that into a decimal. And 5 goes into 48 times. So the probability of not purple is equal to 80 hundredths or 80%. That's the other reason why I like going to the hundredths place. I didn't have to do any rounding in this one. So let's write down my full answer. What is the probability of selecting green? The probability of green is unlikely, 16%. The probability of not purple is very likely. Why am I using very? Because it's approaching 100%. Is very likely at 80%. Hit pause and jot this down into your notes. Let's read through our second problem. A store owner made a list of the number of greeting cards he sold last month. The store sold 167, if I wanted my highlighter, thank you cards, 285 birthday cards, and 56 blank cards. Based on the data, which number is closest to the probability that the next customer will buy a blank card? Right, this is absolutely an SP problem. It is a probability problem. Our key information, we know that there are 167 thank you cards. There are 285 happy birthday cards. And we know we have 56 blank cards. And we are looking for the probability that the next one will be blank. Okay, so here's my strategy. I need to figure out the total number of outcomes. That means I'm going to add up all 3 sets of cards. And then I'm going to change this from a fraction. And I was going to say to a percent, but I realized all my answers are in decimals. And it should be pretty easy for me to identify which one it is as long as I don't make a computational error. So let's make sure I'm showing all of my work here. Okay, and I have my calculator to help me. So I'm going to find a total of 167. These are the thank you cards. I'm going to keep it, look how neatly I keep my work. And I do that on purpose so I can follow along in case I make an error. So I have 167 plus 285 plus 56, and that equals 508 cards sold. And I know that the probability for blank cards, I'll put B for blank, would be 56 out of 508. I'm not going to simplify this, but I am going to turn it to a decimal using my calculator. So I'm going to do 56 divided by 508. And that is going to give me 0.110. And I'm just going to round that to 0.11. Okay, and this makes a lot of sense because the fewest amount sold were the blank cards, so there's no way that, I'm looking at D, I can instantly eliminate. There's no way that 89% chance that the next card is going to be a blank card. If anything, he has a better chance that it will probably be a happy birthday card because more people have bought happy birthday cards. 56 hundredths is very close to half. Again, 56 out of 508 is nowhere close to half, so I can eliminate that one as well. And I know it was unlikely, so it was up to me to just actually do the math to figure out if it was going to be 11 hundredths or 33 hundredths. And in this case, it was 11 hundredths. Hit pause and jot this down into your notes. And again, the biggest takeaway is to represent the actual ratio as a fraction, the number of outcomes we want out of all the possible outcomes, and turn that into a decimal using division. Use your calculator as a tool, but keep your work nice and organized so you can also follow through and ask for feedback from others if necessary. That's it for today, Math Marbles. I'll see you in the next lesson. Take care.